Mary.
Hola, señoritas and señors. Hoy vamos a aprender solving totally radical equations. Okay.
That's Spanglish.
Yeah.
That's pretty good. I know. I'm impressed. All right, I'm gonna run you through 3 scenarios. Okay, that's the way I like to teach radical equations. So since I'm teaching it, that's what we're gonna do. All right, so scenario 1. This is not, if you're a book follower, this is not gonna follow your book because I'm just gonna solve it the way I like to solve it. All right, scenario 1. If you see, first of all, what's a radical before I start going into all this?
Something really
Square root, cubed root, those are radicals, okay? Tell me this before I go into this scenario. What is the inverse operation of square root? Squared. What is, I wish I had that on video. What is the inverse operation of cubed root? Cube. Okay. All right. So what I'm getting at is, you know what cancels those things out, right? All right. If you see one radical in your equation, what you're going to work to do is isolate it. What does that mean?
Get it by itself.
Get it by itself. Isolate it, and then get rid of it. Get it gone. No, it does not sound like a murder, Marshall. It in no way sounds like a murder. Okay, well, maybe the theme for today should have been like horror movie.
Isolate and get rid of it.
Get it by itself and get rid of it. Okay. I see now, Marshall. I see. All right, so let's say this is my equation. I guess if you don't have a little bit of fun.
It's not that fun.
That's right. Okay. So I'm looking at it. It's clearly one radical, right? Okay. So one radical, I need to isolate it first and get it by itself. So how do I get the radical by itself? Minus 4. I'm getting a lot of different answers on that, y'all. How do you isolate it? How do you get it by itself? Well, you move everything away from it. All right, so I have x plus 2 equals 3. Do we all agree? What if there happened to be a number in front of that radical? Like, what if this was 5 times? Then you would have to divide. Okay, very good. I just want to make sure you know that when I say by itself, I mean just radical and whatever's under it. That's it. Everybody okay? All right. Now, how do I get rid of it? Square it.
When you said get rid of it, I thought you meant like we aren't fancy.
Did you say erasing it?
Yeah, because I thought it would be 3. That's what I
Okay.
That's why I said that.
Erase it. Well, because that was a pretty clever answer. Okay, so x plus 2 is now 9.
Minus 2x.
And minus the 2 to get the x by itself would leave me with x equals 7. One radical equations are super duper easy.
Is that a coincidence?
Video. That is a coincidence that it initially started with 7 and ended with 7.
Thank you.
Okay. Questions about this?
Can you show us one that has a number in front?
Yep. Okay. By the way, sidebar, the square root of a number can also be written as this.
Hold on. What's not fun?
Okay. We're going to talk about rational exponents. For some reason, the order that this book goes in, it doesn't really address this until next chapter, but it's good for you to know because you do have some exponents like this. So if the square root is 1/2, what do you think the cubed root would be? So if that comes up and you see it, know that that's what it means. It also helps you to see why it cancels out, right? If to get rid of a square root, we square it. What is, I got a power to a power, so if I multiply, what's 1/2 times 2? 1, which is just x. So you see why they can't, that makes a little more sense as to why they cancel out when you see it written like that. All right, so you asked for one more. Let's do one more. Let's do it with a cubic. So let's do, well, this will be an example. 1/2 cubed root of 2x minus 5 plus 1 equals 2. What?
You're gonna subtract first instead of.
You need to subtract first, right?
Team up.
You don't have any like terms just yet.
I do not. I'm good.
Yeah, that's not in the radical. All right, so subtract 1. Because I'm going backwards order of operations, right? Right. That's right. Now get rid of the 2. Remember, I need to get the radical by itself, and then I can get rid of it. The reciprocal of the fraction. Instead of dividing by a fraction, it's easier if you, oh, this is the easy scenario. 1 of 3. 3 is the tough scenario. It's fun though. Oh, that's right. All math. You could divide by a half, but it's the same thing as multiplying by 2 over 1. All right, now get rid of it.
Are we gonna get this?
Cube it. No, maybe, I don't know. 2x minus 5 equals 8. Yes, you will. Plus 5. This is a super simple now 2-step linear equation.
Wait, you.
You want me to put them?
You cube it before you do it.
Yes. Once the radical is isolated, you get rid of it. It's a very nice pink you're writing in there.
Thank you.
I have a pack of those pens. I like them a lot. Put this in the video. If this was written, you have one that's written this way, and I'm not going to go through and work this for the sake of time. But it looks just like the one we just did. The 1/3 exponent is the same thing, remember, as cubed root. So if you see that come up, understand that's the same thing, okay? So you go through the same process.
I'm glad you reminded us of that because I was about to freak out.
Yeah.
Like, why are you not going to solve this? I
Yeah.
don't know how to do it.
All right. Scenario number 2. 2 radicals.
Go back for 1 second.
Yeah. 1 times up. I'm just kidding. Okay. 2 radicals. Nothing else. Nothing added, subtracted, anything like that to it. It's just 2 radicals, okay? So maybe it looks something like, and I should say this, I should say 2 of the same radicals, same root radicals, like square roots or cube roots don't have like, if this was a square root and a cubed root, this method wouldn't necessarily work. So let's say I have the square root of 2x plus 5 minus the square root of 3x minus 8 equals 0. I have 2 radicals and nothing else. Do you agree? Yes.
Square root.
Before square, nope. Huh? So what you do, you get them separated. My son says that all the time. Okay, so you got to get them separated. Y'all know that song? You got to keep them separated. Okay. Nobody in here knows that song.
I played it on the video.
Oh, it's pretty hardcore, like rock. Like,
It's a great song.
I can't remember. It's probably late 80s, early 90s maybe.
Usually like.
She listens to live.
Huh?
That's like almost 2 decades.
Well, whatever. Okay, if I separate these, it's easier to take the negative and add it to move it, right? So square root of 2x plus 5 equals square root of 3x minus 8. I know.
Is that because there's a 0?
That's because that's what I'm telling you to do. Get them on either side. Okay. There's nothing else. Now, if that wasn't 0 over there, again, this wouldn't work.
So you just drop the minus?
No, you
I added it to this side.
Plus, then you would subtract it.
Yes, yes. Square or cube if it's a cube root. Both sides. Because what's going to happen, and I hope that intuitively you knew what to do on this before I even told you, because seeing both of those on both sides like that, you go, oh wait, why don't I just square both sides? And the radicals boop, drop away. And it's just an equation now to solve with x's on both sides.
X equals 13.
I will minus the 2. And I'm going to add the 8. And I get 13 equals x. I'm going to show you that. You got it? All right. Let's say I have any other scenario with radicals. Let's say, I'm just going to say all others. Okay. You're going to have to isolate one of the radicals. And we're going to have to do it one by one. But here's where it starts getting kind of sticky. And you're not going to have anything too terribly hard just now. But I want you to think about this. What if I had... Oh, maybe y'all's... There are a couple, so let's do it because they're my favorite. All right. I'm going to do this one.
I don't know. Google Translate.
There's a Japanese film with
Okay. Here's what I need to do. I need to get at least one of the radicals by themselves. Okay. It doesn't really matter which one. I would probably, it doesn't, I'd probably move this one over here. But it doesn't matter. So subtract it. Okay, so we're going to get one by itself. Now the only thing to do is to square both sides to get rid of the one on the left, right?
Wait, could you add this 3 into
Nope.
that?
No, you gotta leave it. Now, the left side's easy peasy, right? But the right side,
Oh,
I was waiting. As soon as you see what we're gonna have to do, you're gonna go,
you're gonna have to do
And then
Yes.
do the-
you cannot distribute that exponent because I'm subtracting in the parentheses. So that means
So wait, when you multiply, you make it 3 times the
it becomes positive. All right, so nothing to it but to do it. You have to, yep. X minus 6, we have to FOIL this out. 3 times 3, yes, minus 3 times the square root of x, minus 3 times the square root of x, plus x, because the square root of x times the square root of x is x, right? Anytime you multiply something by itself that are both under radicals, whatever it is, if it's 5, if it's 3, if it's x,
What if it's
whatever it is, it just leaves itself.
What if you have more than one radical, like it's 3 through 3? Does it become radical 3?
What you mean 3, 3, 3?
Like how you multiply, or just x. If you have radical x times radical x is x, what if you have radical x times radical x times radical x?
It would be x times the square root of x. So the square root of x times the square root of x times the square root of x. These two make x, right? So it would be x times the square root of x.
What if you have multiple numbers?
It would still just be a process of multiplying them together. If this was x plus 1, then this would be x plus 1. So the square root of x plus 1 times the square root of x plus 1 is just x plus 1. As long as it's the same, the radical drops, you write it once. Okay. All right, let's clean it up a little bit. X minus 6 equals 9. What is negative 3 root x and negative 3 root x? Mm-hmm. What type of equation do I have now?
You have to do the.
I am to scenario 1 again now. I am an equation being solved with one radical. So get it by itself and get rid of it, right?
Contained all of them.
Good job. So what I'm going to do, I'm going to move everything away from that 6 root x right now because I want to isolate the radical. That's my key in solving radicals, is getting them by themselves, right? All right. If I minus x, oh, how nice. Y'all got lucky on this one. And then I'm going to minus the 9. So I get negative 15 equals negative 6 root x.
You can't get rid of those in bond.
You absolutely do, Eliza. Good job. And Ethan, you divide negative 6. Positive something. How about 5 over 2?
2.5.
Are you checking behind me, Marshall? Do it as a fraction. Math and Renner.
So then you just square it?
And then you just square it. That's exactly right.
So it's 25 over 4.
Yes.
5 over 2.
I don't think I can, sorry, but
25 over 4.
Can you do the other one?
Sure.
Because I'm not
Shh. Here we go. Ready, Freddies?
Yes.
Yeah.
Video, we aren't ready, please.
Lace your boots up. All right. All right. I've already got one of them isolated. Do you see that? I'm not going to double my work by moving stuff around. I'm just going to start multiplying them as it is now. Sure. Go ahead and try it. All right.
I got one. They're sitting in the dark.
I'm going to foil this side.
I'm moving on.
We should do the same.
Because I'm recording now. And I'm going to drop that off there. All right, here's where it gets sticky. When you foil this, the radical goes away there. Square root of x plus 2. Square root of x plus 2. Plus 1. Okay, clean it up. All right, hold on. I'll move that x in just a minute. Let me do one thing at a time. Those two together, so there's 2 of those. Oh, I'm going to do this 1 and 2 together here for 3.
Run with the spicy sauce. Not.
Okay? 2 and 1. All right. Get it isolated. If you need me to slow down, tell me. I'm just going through memory. You know, I gave you time to work it. Okay. I see some erasing and some scratching.
You do the 3 first, do the X part 3.
I'm going to do the 3 and the X. You don't understand? Okay, which part did I lose you on? The foiling? All right. So these two square roots, the square root just drops off when I multiply them. 1 times that is just itself. And then itself. And then 1. Okay? And so now I end up with 2 times the square root of x plus 2. All right, look. Oh, it might, no, this is negative 2x. Divide by 2, so I get the square root of x plus 2 equals negative x.
Is that imaginary?
Because now I'm going to square. So I get x plus 2 equals, oh my gosh, y'all. Oh my gosh, this is so exciting. It's a quadratic.
Wait.
Yes!
Is it x squared or just x? Wait, so negative
X squared. Huh?
Wait.
Negative x times negative x would be positive x squared. Okay, well, so what do you do when you have a quadratic?
You graph it.
I got this nasty one.
Let's factor. What multiplies to negative 2 but adds to negative 1?
1 minus 2.
1 and negative 2. What are the two solutions? How much fun was that?
So much.
Thank you, Adea. I think so too.